Good. Okay, good. Do I see Prichai in the front? Hey. All right, we'll take again, a moment or two for people to show up. We're at 20 in the room right now. All right, one more minute and then we'll get started. So I'm a little confused why the lower Mesher slides are still up. Some more folks filtering into the room. I'm waiting for that magical 9:32 my time thing. Addison, are you in control of the slides?
Yeah, I don't know why I can control the slide from the settings.
I think you have to like do share slides with your slides now.
Okay, I can share my slide now. Do you have any slide for introduction for the GAIA?
No, we don't have any kickoff slides. We do have the agenda, which is in there. So I guess I'll just kick it off though. Welcome everyone to IETF 122's GAIA in Bangkok and online. I am Curtis Heimerl. I'm one of the co-chairs of GAIA. Addison asked to share screen. I'll figure that out in a second. With Jane Coffin, who is unfortunately not going to be able to make it today. She is USAID adjacent and has a very complicated existence at the moment. So I am the one driving the boat. But luckily, I have Addison up front, a colleague of mine who will be speaking here on his own work. And we'll say temporary GAIA co-chair running the upfront desk. The event today, we have Adesoran speaking, we have Felix speaking from UPC, and Dadang is going to speak last on some work in Indonesia. Our fourth speaker unfortunately couldn't make it, dropped out, and so that'll be the set for today. We might have some kind of Q&A around. I'm really interested in at least the experiences people have from USAID and the sort of churn that I've seen in other forces. But again, I tried pretty hard to get a speaker to come in to talk about that, but it's obviously a little, I would say, raw and or sensitive at the moment. So perhaps a discussion that can happen a little later on. But for now, if there's anything anyone would like to add to the agenda, feel free to stand up or raise a hand or these kind of things. Otherwise, we'll kick off the talks with a local speaker here, Addison. Okay.
All right. Okay.
Seeing none, I think the table is yours, Addison.
Okay, let me start then. So first of all, thank you, Curtis, for invited me to update our works on our new project, which is being related to. I need to click on this one. Oh, sorry. Yeah, on the project. I think the mic might be easier. Sorry. Yeah, on the project that we try to measurement on the air pollution with the frontline workers. That is, as you can see from the topic, air pollution on the move, the study of PM2.5 exposures in urban delivery. So these works have been a joy working with many institutions. As you can see, me and myself from the Interlab AITs, and also we have been joy work with Curtis from University of Washington as well, and we have a folk colleague from Chiang Mai Ratchapat University and Thammasat University as well. Okay, let me start to that. So the problems that we can talk today is more or less about the air pollution. I think all of us know, and even eventually you came to Bangkok, right? So we are in the crisis of the air pollution right now. So, and the main killers, the main sort of the problems that we, as we know, is related to the PM2.5, which is the full name is called particulate matter, which have the size really small that you can inhale directly to the lungs, and then they can cause of a lot of effects. They see lung cancer, stroke, NCD, etc. No, and then now for Bangkok, it's ourselves. We've been facing this problem for long times, and then recently, if we look into some kind of statistics about the medicals that people want to seeking for the treatment for the air pollution stuff, like we found that like in 2023 is about 9 weeks, the people have been 1.3 millions, and then the number increased significantly in 2014, like from 1.3 to 1.6. So this has become like a critical situation in our country, and also spreading out all the Southeast Asian regions as well. So, and that we try to from that we try to do some kind of data analysis a little bit, like before starting the projects, right? So we have a curious about what would be the air pollutions in Bangkok, and also yeah, we take the sample from Bangkok and Chiang Mai, just be the two major cities in Thailand. So the data we taken is from the air quality station that's owned by the government agency called PCD, Pollution Control Department. So we take the data from the all year longs, and then like you can see from the x-axis, and then on the y-axis is showing the average concentrations of the PM2.5 from both stations. So not surprisingly, we have seen that. So actually, the borderline within the safe limit is about 15 microgram per cubic meters. But you can see that most of the time, so we have been violate that thing. And looking to the more study data, what should be the critical periods, right? So mostly it happens in the dry seasons in Thailand. So in Bangkok, we have facing a bit early, about January to February. Now in March, we been quite okay, but it's been in the middle or start of season in Chiang Mai. So if you are going to Chiang Mai right now, so please wear your mask and then be careful for that. So then we also have a curious about, like, if we want to spend our life in Bangkok or Chiang Mai, right? So what could be a good day and the bad days in the over the year? So that we also taking some statistics as well with the same data, but we comparing with the reference air quality index. So you can see that we can map the concentrations of the AQIs that we measure that, and then matching with the color, like blue, green, yellow, orange, and red. I think this is the same standard with the AQI that you open. Many applications provide that one. So now you can see that, okay, Chiang Mai is quite been okay, because you have some day, many days. Oh, sorry, my slides is missing something. So it's about 140 days that we have been excellent, considered excellent day. But in Bangkok, we have quite been sad. We have very few days that we can consider as an excellent day. But we still have some green and yellows for Bangkok. But for Chiang Mai, so the most they trade off with a very a red and orange day. Eventually, so we try to just classify them, like what could be unhealthy days and quite okay days. So I put the borderline here between orange and red, and that the air quality is beyond that one we can consider as unhealthy. So a coincidence, both cities have a same day, that number of days that have been about 96 days that have been equally considered as the unhealthy. So it's about 20. I'm missing this number. Sorry about that. So it's about 24%, and then the yellow one is about 26%. That means it's about 1/3 of the year we still have quite of an okay day for the good air for breathing. However, to matching to the GAIAs, So we are talking about like global access for all, right? But in this work, we're thinking about like the global access is being into the data as well. So we thought that at the beginning we start the project, we thought that so those data might not be reflected to all people who living in the country, and then we will consider about the people like vulnerable groups like motorcycle riders, like food delivery. I think some of you might be using that service already, like ride sharing, parcel deliveries, construction workers, street food vendors, or some kind of cleaner on the street. So these people have been risky because they have to be long working times on over the streets, and then they also heavily been busy, so they don't have a chance to take absent, to take a leave for medical checkup, and also they cannot afford for the full medical checkups as well. And also another thing is that these people have been very risky because they have been very close to the air, the exposure. So just refreshing about some things. What about the government? What try to do? So the government try to proposing like a Bangkok metropolitans. So we try to propose many mitigation for criteria like the people can have work from home criteria, and school kids can be also closed, and then student can to avoid some kind of pollution, and also to reduce some kind of expose the pollutions as well. But however, those policy cannot apply for these people, and then these people have to be still working on that bad situations. So, and that is we become our motivation on this work, right? So we have skeptical like what should be the actual number, actual concentration of these people that been exposure at Zoom every day. So to start with, so luckily we could before this project we have running the project called CHMON already. So this is kind of building the IoT platforms, Internet of Things. So we are producing the kind of IoT sensor that been measuring a lot of parameter on the air pollutions like PM 2.5, PM1, PM10, carbon monoxide, CO2, temperature, humidity, and everything. So we can add on the sensor on that. So this project is have been running for a long time, for a couple of times. Like we start from 2016, and as you can see, we have a lot of partner, and then also a lot of funder helping us as well. Part of them has been Europeans, EU as well, with through the Asia Connects programs. So now we have been expanding out the platform to I think 7 countries already. So at the beginning we have Thailand, Indonesia, Philippines, Laos, and now we have Burma, and also recently we have Nepal as well. So, so we want to expand utilize this platform to be more for the riders as well. To start with, we at the beginnings we start this project on May 2013. So we just want to use our sensor, and then we planned it. Okay, we can put them on the motorcycle, but quickly we realized that this should not be the real exposure, because what we try to do here is like the exposure on a motorcycle, not the human itself. And then quickly we try to revise our version, then try to put the sensors on the with crazy ideas on the try to put the sensor on the helmet. And because the sensor should be more close to the nose, that is will be actual exposure that we can measure. But sadly, because it's too heavy actually. So I asked my student to sitting there, and he said that he cannot stand for half an hour because it's too heavy, and then it's not really comfortable. And then so we realized quickly about 2 months, so we end up we try to spread these two, and then to try to making a very slim and thin and lightweight, to put really a major part with the sensors on the helmet, and then we left another competition part like storage, and then connectivities, SIM card, and 4G in on the control box, and then we put them on the life waist jacket on the help and on the rider. So that is our final prototype for the measurement. So now we have been ready. So, oh, sorry, I lose my controls. I think my controls will be with Curtis.
Oh, sorry. Dirk emailed me saying we should try this clicker thing. So does the clicker work now?
Yeah, please. Next slide, please.
Well, no, I mean, does the clicker on the desk, does it work now?
No, it doesn't work.
Shit. Okay.
No, so you have to assign control to this clicker, so you can do this in the.
I think it's work. It's work. I can control now. Thank you.
Okay, great. Yay. Sorry about that, Addison.
Okay. So Okay, then okay, we are ready. So this is the overall architecture. So the main part, the core on the core part on the server side is still we are using benefit from the CH1 platform. So we have the storage with the database and then the simple web dashboard, and this is we also using the visualization on that to track like how the rider is movement. So oh yeah, I want to mention that not only the sensor that we put in, we also push the GPS sensors on these units as well, so we can track them how they move, and then the air pollution is on the move as well, and then we map that pollution with the position of them. And we also integrate with the notification system. We're using a line. This is the chat software that we quite be famous in Thailand. So we're using them for their two purpose. The first purpose is like we warning them as well. Like if today is quite been a bad day, so you should avoid some activities and then put some mask. So we send that notification to the riders. And the second purpose, we want to monitor our node itself. If something wrong, so we can send notification to tell them, okay, please set up, or if something happening, just do some kind of hard reset, something like that. But for the first purpose, we fail because we try to warn them, okay, today you should not go to out for work, but most of them ignore that our message, and then they keep working because they thought that working and then getting some money is more important for their health. That's in some the storyline that we want to tell. All right. Okay, and this is our volunteers. So we managed to recruit 5 riders, mostly from the Grabs. This is like these food deliveries, 5 in Bangkok and 5 in Chiang Mai. And then we ran the measurements over 7 month period, starting from November 2013 up to May 2024. Is about 7 months. So the purpose of that because we want to capture something before the air pollution episodes begin, because as from the start the episode start from January, so November December is called the good timing, and then we have been during the episodes and then after the episodes as well. So not surprisingly, because this is our first trial data that we got from the 2 rider in Bangkok and Chiang Mai. So the measurement here we measure on in the November, which is not been a critical time yet, but you can see a lot of red spot there. That means these area and these area they have been consumed for the too much air pollution, so that and quite been risky for them. So also because we want to compare also validate our data as well. So we have been, of course, we have the data from the air quality station, from the PCD, but we want to be not to be biased. So that's why we benefit. We try to utilize our HESMON node. This has been deployed already in the city. So this is in Bangkok area. So we have about almost 10 nodes that's been deployed already before the projects, and then we validate with them. And also in Chiang Mai, we are more focusing on only the, the center part of Chiang Mai, not because Chiang Mai is quite big actually. So we've just been focusing on like the core part of Chiang Mai here. And this is our study area, and then this is the static node that we want to validate our sensor with. Next, okay. So this is our first look of data. So how it looked like from over 7 month period. So we divided in Bangkok and Chiang Mai here. So and then on the y-axis is the concentration of PM on a daily average. And the solid line here is showing the data, average data from our static station that put in on the buildings and on the roadside unit. But yeah, following our assumption that so these people, and then the dot line there is showing the exposure from each rider. As you can see, so most of them, like most of the rider has been more violet, higher than the solid the station that we put on in the city. So taking examples in around February here, so we have the static station report about 100 micrograms, but for the measurements from the rider has been about 100, more than 150. It's about 50% more than the stationary station. Similar trends going happening to the Chiang Mai as well. Like as you can see, most of the day, like the exposure from the rider has been higher than the station, but except in the part on the peak period about in April and May, we found that in Chiang Mai at that time, like March, April, the air pollution in Chiang Mai is very high, like about 200. And then we found that the X measurements from the rider get a bit lower than that, because this is because of the wind. Because when you're being in the very high concentrations, right, movement might help something to get some fresh air, and that we found that phenomena in Chiang Mai, but not happened to Bangkok. All right, then we want to compare to the some guidelines, and then we take the borderline here. That's a recommendation from US EPA. So what could be the level that been safe and then recommended by and then the borderline that is about 15 microgram. And you can see this is the box plot, and then you look into the medians, and so most of them have been violated to that. Like they on average they could get about 50 microgram, which is about almost 3 times, more than 3 times compared to the borderline. And then seriously looking to the peak. So this Chiang Mai 2, the Chiang Mai rider number 2, the concentration is reached up to 300, which is about 20 times over the safe guideline limit to that. So that means related to the health. So now we are very concerned about all these people, because they have been more consumed on the air pollution, and that something should be happening to them, so on the health. So sorry, this has quite been very messy here. So this is kind of we do another visualization, try to mapping the concentration of each riders. So the column right is showing the day, and then is cell showing the concentration of PM2.5 of each rider, and then we map with the color that I showed from the beginning. So as you can see, this is the peak period in April. So most of them have been red and orange. So that means they have been quite very, very risky for their health. So we're using the same criteria like blue, green, yellow, orange, red to mapping like how many days it's been polluted and how many days it's been okay day. So we use the same criteria by counting on like if the air the exposure is beyond like 37.5. So we counted on the bad day or unhealthy day. So looking to the example of the BKK1, the rider one. So this guy a very workaholic. So we have the measurement for 197 days. He only took the day off only 3 days, but he keep working on continuously about 194 days. And that counting on the air pollution that has been exposed to him, so about 70% that he been facing on the very unhealthy day, unhealthy for him. So compared to my first slide, so we have about 24%, right, that been unhealthy, but these people is with 3 times have been facing to that. So that is kind of our first result. That's why to be finalizing that, like so try to summarize, like these people have the air quality data that have been seen on applications or report by the government data is not reflected to all people, and that is some kind of my my key takeaway that I want to mention here. So these people, these vulnerable groups, like has been facing the extremely high pollution exposure, not only few days, but they have been continuous like for many days, and then for the long period of times as well. And also the mitigation strategy should be adapted, customized for this kind of people, because the policy from government might not be applied to all of them. So yes, from some quick ideas that could be the key takeaway, like proposing them some day off, or proposing them some few hours for the for getting some refresh air should be helped a lot. But of course, we need to think about how to compensate all the economic that they cannot work as well. So that kind of thing is a complex issue that hopefully the GAIA community should help to forcing this kind of policy for that. And also another thing is like a healthy assessment should be think about, and then try to take, for example, take these people to do like fully medical checkup, and then investigate fully like what would be the protection, the treatment that they would need. And also another thing I've already mentioned several times, like report air quality data from static station, either from the AQI for IQ air, or the government system might not be reflected to all the people. And that is our first step showing that that's our assumption is true. And lastly, what I want to mention, because I'm keeping saying about this, I have a lot of arguments, a lot of my presentation and talk in another way, and it was like, should we rely on the low cost sensors? My answer is like, yeah, yeah, pose it should be a yes or no, because if you want to compare the data from the low cost sensor with the station that I mentioned from the beginning, that is not comparable, because with technology itself and also with the cost, so you cannot use compare. But if you want to observe the trends or kind of average those kind of thing, the low cost sensor can answer that in that particular solution. And also taking example of these scenarios, so we cannot take the station to be carry-ons, right? So this low cost sensor is portable, low cost, that can be deployed everywhere. So these are pros and cons that we're gonna use. So I think if you answer myself, the low cost sensors will benefit, and then we can use them in many scenarios, but that the standard station cannot be cannot be used. All right, I think this is my end of my slide, and then I think I keep my time and then open for the question. Thank you.
Thank you so much. All right, audience, I see a Benson. You want to start kicking it off?
Okay. Thanks for the very nice presentation. I'm curious if you've also looked at sources for pollution. So, for example, if the government decided that motorcycles or new motorcycles should be electric, would this have an impact on reducing pollution?
Yeah, that would be the solutions as well, because so now I take example for Thailand. So the government try to be encouraged a lot to try to like reducing some tax to then encourage people to change their car to be electric, but it's still ongoing. So now if you measure the air pollution in Bangkok, I think it's try to be reduced gradually. But for the rider itself, like if we want to encourage them to change from the motorbike to be electric bike, that is still some kind of complicated, because uh, during our measurement we also asking like these people as well, like how they do for their motorcycle. So they have to pay their own. So right, like most of the rider that have been loaned the money to pay, and then they still paying the debts for that. So if the government forcing them to, okay, you need to change to the electric bike, I think we're gonna put more burdens on them. I think some kind of electric should be take some time, and then and also I'm thinking that the government should be subsidized somehow for that kind of to lift up the people to change from the electrics. Yeah, that is my thought.
Just to add on lightly to that topic, as someone else on the study, I remember, Addison, you probably remember this more than I do, but there is that I don't know, there's some study that said basically most of the pollution was coming from the burns nearby. I think Sumatra and Burma, right? And so the kind of stuff that we're talking about might not
Yeah.
meaningfully move the needle anyway.
Yeah.
Alistair?
So yeah, that is different problem, because in Bangkok it's about electric car city, but for Chiang Mai, I think we are facing on the not from the vehicle, but we get the pollution from the forest fires. That is another project that we are working on as well. Like we try to use a low cost sensor to detect, and but I would not want to say like, okay, everything is from our neighbor, but also in our country itself, we also main sort of producing that kind of pollutions as well. So, but that problem is quite been complicated to solve. But if you're asking my thought, what I'm thinking, like we should working on ourselves, like we try to manage like in our country first, and then we can use diplomacy to working on like some like, international level.
Alistair Woodman, could you talk about the how you calibrated the low cost sensors versus your standardized sensors? Did you actually try to check whether they, or did you assume that there was some offset drift and then try to figure that out over time? So how did you deal? So were you able to use very low cost sensors that were not perfect, but you could figure out the signal and noise or the offset from the data?
Yeah, that's crucial actually. Yeah, actually, all the sensors that we have been produced, before using them, we have to calibrate with this station. But I didn't put it here, but that is on our previous on the prior work. So yeah, we have some technique that following by the US EPA. So like we need to put all the sensor that we have been produced in the same, we call it co-location actually. So we putting them here on the top of these stations, and then we keep running the measurements for some time. I think the recommendation is about 60 days, 2 months. And then so we are plotting kind of and then we plot some kind of linear equation to be adjust that. So each sensor have the equation that after the calibration that we like try to wrap it up.
So you're also saying that the sensors are actually non-linear, and then you create, you convolve back a linearization by, okay, thank you.
All right, and our last question from Iram.
Thank you. Aram Welling from Oxil Information Lab. So, you know, the joke in the US is always that people are required to get their cars emissions tested, but the trucks are not, okay? And we know from some of these studies is that the significant air pollution comes actually from the trucks. It's not from the people who have cars that are less than 5 years old, but are required to get emissions testing. So what I would ask is that, you talked about, somebody mentioned, electric bikes. Are you guys considering putting more of the burden on the companies that may have some money to actually do some kind of IoT sensors, studies related to their contribution to the pollution issues, and be able to address policies, even if it means spreading out their routes, right? Taking a different path. Don't go through the city that's already got other contributors to the air pollution. Maybe take a different path, or some other avenues. But I would say move, at some point consider moving towards the corporations and that are utilizing and actually producing a significant amount of air pollution. It's not the people, it's the companies. Thank you.
Thank you. Yeah, that kind of remind some idea that we discussed. Actually, yeah, I like the idea like that the alternative path. Actually, another side of work of this one. So we have tried to some kind of recommend them to try to avoid some kind of path, maybe, and then also taking longer. But it failed because we try to convince, okay, you should go this way. I think it can reduce some kind of 30% of the air pollution, but most of the riders, they don't want to do so because they want to keep their own and then try to be quickly to destination to get, they think about more economics more than their health. So that I think, I don't know how to solve this problem, but as a data scientist, we just report this thing, and then hopefully like governments and something try to take this spot and then develop some kind of policy to all of them. So that maybe it just answers some of you, but
Great. Thank you so much, Adisorn. This is a fantastic talk. And thank you so much to everyone in the audience for the questions. Felix, you want to take over?
Yes.
Passing you slide control.
Can you change the slides?
Yes, I can, although I think you should, because that will give you control over the next slide stuff.
Oh, I think it's still mine. It's still me. Oh, okay, now I cannot. I'm not in control right now.
Yeah, I kicked you out. Felix is in control now.
Okay, you kick me out.
I don't see your slides anymore. Okay.
right.
Looks good to me. Do you have
Yeah.
control?
Yes,
Excellent.
it works. Okay. Yes, so should I start?
Yeah, go for it. It's all yours.
Okay. So I'm Felix Freitag from the Technical University of Catalunya in Barcelona in Spain. And I want to present you a connectivity solution that is using LoRa mesh networks. First, I want to position what are LoRa mesh networks. LoRa is a technology for communication that probably you know more better from the LoRaWAN architecture, which is what almost everybody uses when they use LoRa connectivity. LoRaWAN is a star network where you have a gateway in the middle and you have sensor nodes with at one hop distance to this gateway. And these sensor nodes send data to the gateway and to the internet. So this is the typical usage of LoRa communication in IoT applications. So in LoRaWAN, you're not able to communicate nodes with each other. Every communication goes to the gateway. In the LoRa mesh networks that we see in this picture, we have a network where nodes can talk with each other, and they can talk over multiple hops with each other, any node to others, and there can be multiple paths to a destination. So we have this mesh network when we use LoRa as another way of network topology. So it gives you a LoRa mesh network, and this slide I wanted to check what are the good and what are the limitations of LoRa mesh networks as a connectivity solution. So in the good parts, I think, first is the affordability, because it's very cheap. The hardware is very cheap, and the operation of a LoRa mesh network, I think, should have no cost. So really very affordable solution. Another good point, I think, is it's very fast to deploy. You can have it like tomorrow. You don't. It's just getting the nodes and switching them on, and they self-configure to form this mesh network. So it's very fast to have this connectivity. And another point, I think, is the technical knowledge. If you use a pre-configured system, I think you don't need to have any technical knowledge. It will just work. And if you want to customize, you need engineering knowledge. So it's, I think, within scope, what is the technical knowledge to run such a network? Another, I think, good point is that you don't need to have any installation or telecom mast or something like this. You can put nodes everywhere. And the energy is low. You can use solar panels to power them. Another point is the LoRa frequency is unlicensed, so you can run a LoRa network without paying any operator. Okay. Another point, the hardware is off the shelf. It's not a special hardware. There's many options to get boards with LoRa radio. And finally, you can run lightweight applications that I will explain later what they could be. So, now the limitations, probably the biggest thing is that data rates are not high. You have low data rates, maybe in the kilobit per second range. So it's not something that it's not a connectivity that will give you or replace any cellular network that you could have. So it's not for high-speed applications, but still sufficient, like for sending text messages. This is possible. Another limitation, currently there are no standards for LoRa mesh networks. No standardization yet. That is also a limitation. And then communication is not real time because over multiple hops, you can expect a delay. With implementations, there are not many available, but one of them that I want to explain here is
Hey Felix. Hey,
Yeah.
are people hearing weird artifacts?
There was some noise, right?
Yeah, there's some kind of weird noise going on.
Yeah.
Okay. So, right. So, yeah.
Someone is talking. I didn't even think Michio would let
Right.
people
Thank you.
speak.
That's clear.
What is going on?
I continue, right? Right.
Probably. I mean, if it stops, otherwise it made it a little hard to hear you. Yeah, Edison's turning off some mics, hoping for the best. Thank you.
Okay. Now, one of the technologies to build LoRa mesh networks is this library that is called LoRa Mesher. That we've started it like 4 years ago, and it's open source. It's available in a Git repository. You can download it. It uses implements a routing protocol to send messages, and you could build this kind of network that we see in the picture. So this should be no problem to deploy it with LoRa Mesher. I think there are like two options to use this connectivity. One is more for processes or for machines, devices. You can, because you when you use these nodes, these microcontroller boards, you have some computing and storage capacity. It's not only the LoRa radio that you see in these boards. There's the antenna and there's a LoRa radio, but there's also a microcontroller with some storage and RAM capacity. So you can run the LoRa Mesher code with some application code as well. So it's possible to build like distributed applications. But in this case, it's not really for humans because you don't have the interface, the graphical interface. So it's a solution to, let's say, connect devices to the internet and also to receive messages from the internet. So this is one connectivity that we can get. And the other one, if we want to involve end users, is a solution with smartphones that the Meshtastic solution has like popularized. It is the end user uses a smartphone that the end user knows, and it is connected over Bluetooth to a LoRa node. Then they have this like communication substrate from the LoRa mesh network, and then the users can communicate with each other and also principally also with the internet over gateways. So these are like the two types of applications that this connectivity would allow. Now, does it run or does it work? Yes, it's operational, we have running this network monitor for some months in our campus. It's about 10 nodes that are continuously sending data, that so we can plot this network topology. It yeah, here's the link. It should work. So yes, it can run. It is stable. You should not overuse use it, but yes, it's operational with 10 nodes, and we know from other people also that they use around 10 nodes. So yeah, it works. So yeah, and yes, more about experimentation. Here, this is a screenshot of a routing table from a node. This is a node, a network with 14 nodes, and we see the routing table has the metrics to the other node, and also in the role column, it shows you which nodes are the gateways. That is important to connect to the internet. Yeah, so routing table. This is another experiment. Here we use large messages to send. Well, large messages in terms of LoRa is a 1 kilobyte message, because LoRa packets are 256 bytes. So we can send large messages with delivery guarantees with LoRa Measure. And yes, this is 24 hours trying this. We monitor the message counter. So yes, it also works. This is 4 nodes. And this is another test with 14 nodes. Here we send smaller payloads, I think less than 100 bytes, to other nodes. And also we see with the message counter that the messages arrive. So this type of network should work and can be done. It can be made operational. Now I have a few slides for like how would you use or develop with LoRa Measure. If you can take a predefined configuration, or you can also customize it. And this is also possible. The code is in this open Git repository and you see from these numbers that actually other people also have used it, and they also have given some stars to the repository because they liked it. So you have the code is openly available, and then you need a few of these ESP32 boards to develop and test the LoRa mesh network, like here that you see in the picture. And yes, for trying, there are a few examples in the repository. I think if you have some previous experience with embedded system programming or usage, then it shouldn't be any problem to try the examples and get something running, and from there you can customize or do make extensions. So I think it's feasible if you have this initial background. And also there is a mode to enable log messages that helps to see if an implementation or if a change is behaving as expected. So we can see the behavior of LoRa Measure. If we have done any change, we can see if it works as expected. So this is if you want to use LoRa Measure or try it for yourself, so you can do it. I also included like too technical details. This is not to understand it in detail, but to know that this is there. So LoRa Measure uses a task-based organization. It's not a sequential program. Task-based programming in base system is not strange, but it's well, it's different to a sequential program. So we use these tasks, and we use FreeRTOS. That is a very mature framework to have tasks in a code for embedded systems. So we have like 6 tasks in LoRa Measure that organize the routing protocol to receive messages, to process, to send messages. So this is how LoRa Measure internally works. And second detail is that we use queues. That often is related when you use tasks. You also use queues. But here is it is good to we have these queues to store messages, so we don't lose messages that are sent in the LoRa mesh network. Sometimes nodes have to store these messages because they cannot process at this point, or they have to send it out later. So queues help not losing any message in this LoRa mesh network. And so while delivery is not real time, the message is not, the packet is not lost. It will should arrive at some moment, because we have these buffers, these queues where messages are stored. And here are some points that I didn't know where to put in other slides, but some considerations I think that are interesting. So how is this connected to the internet? How does this give access to the internet, these LoRa mesh networks? You can go to the internet over gateways. Specifically, we use MQTT. So it is bidirectional. You cannot only send talk with a service in the internet, but also the service in the internet can talk with a LoRa Measure node. The LoRa Mesh network does not have IPs, but it has other addresses that can be addressed from the internet over this gateway. So it's possible to talk with a specific node from the internet. And I think this is very interesting to integrate this network with internet services. Yeah, in terms of standardization, this is really lacking. We are not. There's no standard for these LoRa mesh networks, so this is something missing. Another point to take into account is there could happen this tragedy of the commons. The resource which is limited is the amount of traffic that can be sent. So if there's too much traffic, it will become unusable. So this has to, I think, in practical usage, this is important to limit the traffic, because then if everybody sends too much, it will not work for nobody. So, and the library itself, well, we have now a certain community, and we know there are people that include, also they use it, some people use it professionally, this LoRa Measure. They have some applications that are commercially sold and that they use LoRa Measure. So there's a certain community, but still, especially more developers would be useful to have. Finally, the link or the relation to community networks maybe is also important. Community networks are one of the solutions to to connect areas or communities to the internet, but mostly these are wireless Wi-Fi based community networks. Yes, it's like I think related to the idea of LoRa mesh networks, but the performance of Wi-Fi is much better. The network connectivity is on data rate is much better, but it's like the same way you can add nodes, and maybe in the LoRa mesh network the operational is easier, but on the other side the data rate is not very high. And just the main points. So performance. Yes, we have this connectivity solution. I think yes, there is this technology that I commented, the LoRa mesh, but there's also another one. So the technology is there. It's operational. The performance is in terms of data rate is not high, but it gives you a very quick connectivity. The cost is extreme, I think very cheap compared to other solutions, and the deployment time is nothing. It's just getting the nodes and switching them on. Then you have the network. It's auto configuring. It's nothing to do. So it's a solution to have a network like tomorrow. Maybe a niche area is that this network also can be deployed very quickly and also shut down very quickly, because if you want to have it like just a few hours, it would be possible, because nodes can be located everywhere. You can just put in the node and start it, and it will connect to the network, and you can make this network very quickly and also switch off the nodes, and it has disappeared. Yeah, and technical knowledge. Yes, I think it's engineering knowledge that you need to customize or to operate this network. And the knowledge is open. At least our publications are open access, and there is no standard that you have to buy. So yes, knowledge is you can access the knowledge, and yes, there's no standard way. For instance, here in this picture, this is our format of the packet, but it's our decision. It's not something that was agreed with other groups. So we lack this, I think, this standardization if LoRa mesh networks are continuing. So this would be good to do in the future. And yes, this was my. This is now the last slide. So again, this is our repository, and we also set up a Discord server to talk with the people. Okay, thank you.
Wonderful. Thank you so much. As per before, if people want to jump into the queue, I have a few questions, but I'll give the queue a moment to be jumped into by others, and trying to negotiate our third speaker through the Meet Echo login at the moment as well. So Addison, you want to jump in?
Yeah, I have a question, Felix. A very nice talk. My question is about, I want to ask about the multi-hops. So in your LoRa mesh, right? So how many hops that can be handled in your LoRa meshes, and if there are any tolerate when you have like multiple has been applied, like the signal can be dropped drastically if you have like more than 2 or 3 hops or not. So that's
in experiments we have tried, I think, up to 9 hops. and it worked. It just takes time until it arrives from the source to the destination. There's a delay in every node, but if they are interconnected, it arrives. We tried up to 9 hops.
Oh, that's good. A good number. Another question just following up, like, do you, have you managed to try to what about duty cycles for sending the data from each node? You control them, or you can, if I want, for example, you want to get more bandwidth, right? Like have some queue to manage, right, and then I dedicate some node to be sending to get more continuous, to gain more data rate. Is that been possible to do that for like configuring on our own duty cycle?
Yes, it's a configuration parameter. And also the duty cycle depends on the frequency, the specific frequency of LoRa. Some frequencies have a duty cycle of 1%, a few have of 10%, and then there's also a frequency band without any duty cycle. It's a configuration parameter that you can choose. But if you have no duty cycle, it's not necessarily better, because if there's too much traffic, there are many collisions, and then you don't get a good performance. So maybe it's good to have some duty cycle limitations, because it will reduce traffic, and at the end you get a better data rate with it. But it's a configuration parameter.
Okay, thank you.
Okay.
Next up, we have Benson.
Thank you very much for the nice presentation. I'm curious what applications are you using it on campus, and have you experienced excessive traffic?
Yes, if there's too much traffic, it gets saturated. We notice this. We have to be careful how often the messages are sent. The more nodes participate, we have to reduce the periodicity of sending messages, because yes, they are stored in queues, and we use often we use reliable transfer. So messages which are not delivered are retried to be sent, and if there are too many messages, it saturates and the queues get very high. It has to be controlled. There's not really a mechanism to do. I think it's experimentally see how many messages you can send to not saturate the network. And the type of application, the classic one is the monitoring, which basically is also our network tool that I showed in the slides. Nodes are sending messages to a gateway, and the gateway connects to a service in the internet, and so we can plot the values of the nodes, or it could be sensors as well. Typical monitoring application. So this works, but I think the most innovative idea is to talk from the internet with nodes. That is what you can do with LoRa Measure, and this is not possible with LoRaWAN. You could really talk to a specific node, change configuration, or ask for values. This exists. This bidirectional communication is possible, but we have not looked for applications that could do it. But this, I think, is a possibility that is very unique.
Thank you.
All right, and I'll jump myself into the queue. I think it might be I think the other presenter did not quite get the fee waiver in place, so you might be it, Felix. But I'm curious about the standardization question that you had at the end there. Mostly in the sense, obviously, we're at the IETF, and this is a place where standardization takes place. Now, of course, LoRa is, I believe, an ITU standard. And generally kind of physical layer stuff is not in scope here very often. But in terms of what you guys have built and then Meshtastic, is there much difference between the two in terms of the designs at that higher layer? And why do you think, or do you think, the IETF is the right place to standardize the work that you've been doing?
Yes, with Meshtastic is a very, I think, very nice project. It's more mature than ours. The difference in the upper layer, I think they are not doing routing. They don't have a routing protocol. They use gossiping to spread messages. So it's an alternative that can be better or worse depending. So they have destinations, but they are not doing. They don't have routing tables. So their mechanism to reach destination, I think, is gossiping. I think this is the difference on the network protocol with them. And but I think for this idea of text, sending text, they make it very good. That is their application. I think probably maybe in LoRa Measure we can actually run several applications on a node if we want to. It is supported, and probably this is not possible in Meshtastic, I think, because their main target is the text messaging between people with smartphones and using Meshtastic as a network substrate. So I think Meshtastic, yes, they are, I think, very mature to perform this text messaging service for people if this is the target. And the standardization, I'm not sure how to start this. There is this LoRa 1, which is a standard LoRa 1, but we are different, and we are on top of the physical layer, but I'm not sure how to which group to reach, how to do this. But it would help because we have designed it at our own guess, and it's not agreed, and it should be agreed, and yeah, it's a missing piece.
I mean, standards can come out of GAIA. I think y'all's group is pretty central to what we've been doing here in GAIA for so long. There might be other groups, I think, that would have perspectives they'd like to add as well. And if anyone in the audience has sort of perspectives on this question, I think this is a welcome spot for that discussion. But I see Dirk, you're up next.
Yes, thanks, Dirk Kutscher. So just one kind of IETF comment. So, I mean, let's be conscious of what we are doing. So we are a research group here. Like, we are doing research, not standards. So regarding like the protocol question, so I mean, LoRa, as you probably well know, has like a physical layer, right? That's designed by a company called Semtech. And then there is the LoRa Alliance that has produced specifications for LoRa WAN, which is this vertically integrated stack with like a network or cloud-based gateway system. Now, on top of the LoRa physical layer, you can of course build arbitrary or like different types of MAC layers and network layers, and it has been done in research. So people have been running IP or information sending networking on top of these systems, and that could indeed be interesting to study. So if GAIA wants to do something in this space or study this further, I think it could be quite interesting, especially with this mesh network focus for GAIA scenarios. Having said that, of course, we also have the Think-to-Thing research group in the IETF might be worth talking to those people, and I think they're also discussing topics like that occasionally. Yeah, and we should be aware of indeed what's actually going on in the IETF IoT space. So, I mean, we have technologies such as 6LoWPAN, CoAP, and so on, and they have also been developing developments using these technologies in LoRa scenarios. So I think that would be good to explore a bit more.
Any thoughts, Felix?
I've heard about this IoT working group, what you mentioned, but I'm not aware about the details, what they are looking at. Yes, as you said, there's this LoRa Alliance, which is LoRa One, and it's on top of the physical layer, and LoRa mesh networks are another solution on top of the physical layer, but it's not using LoRa One. Yeah, but LoRa One is standardized, and LoRa mesh networks are not. Yeah.
Yeah, I could imagine if there are competitors for LoRa, and I'm not deep in that space, but trying to build something that could operate across multiple of those does seem like an IETF-able kind of question, and the things working group does seem like a good fit for maybe you to present at the next IETF. We can try to get you connected into those folks to get their perspective on the problem you're solving and the stack that you're using and the right way to integrate.
Yes, maybe it's good just to have like this list of options that of groups that could be approached, that what Dirk mentioned. Yeah.
Great. Okay, thank you so much, Felix. Unfortunately, I think we are done. Our last speaker, I think got very confused, which is too bad. You can go look at the slides. I'll just pop them up here to, wait, I have to take the slides back. We have some really cool stuff lined up on it's a community, community fiber wire network in Java that I was really excited to hear more about, running fiber poles through the trees. I think fiber to the home and kind of fiber community networks is something I'm really excited to hear more about. But unfortunately, got caught in some of the getting through to meet echo confusion. So hopefully we'll have them in for the next one in Madrid. And just as much as we had Felix here for Bangkok, will bring the Indonesians out to do a talk for Madrid. But otherwise, thank you so much to Felix and Adisorn for talking. And we'll call this for now. And I'll see you all in Madrid. Thanks, everyone. And thanks in particular to Adisorn for manning the front desk and turning off microphones.